The way Eloque works is we've got sensors that we apply to a bridge. These sensors then tell us what's happening to the bridge, and we then turn this into really understanding overall what the bridge's behaviour actually is.
These are fiber optic based sensors. It's a reliable technology. It's low power, so we don't have to consume a lot of power. So they're orders of magnitude more sensitive than traditional sensors. The technology allows us to deploy seamlessly and at low cost a large number of them.
From this, you then get other insights into what you might have to do to look after that bridge or that asset. One of the core parts of our installation process is actually the calibration process. So once we've gone out and installed it onto a bridge, it's critical to know that what we're getting off the bridge is in fact what we believe it to be. We have to run loads over a bridge to understand that is it reacting in a way that we would imagine, considering what we've put over with these known factors, so that in the future, when we have unknown factors, we can determine what it is that's actually happening. One of the important things about having a sensor system like this on infrastructure is being able to understand how it performs long-term and under known conditions. So this rig here is set up in the Palo Alto Research Center car park and basically looks at something replicating a small beam. The beam itself is sensored up in the same way we'd sensor up beams on site. And what we're looking at is how are these readings changing over time and how is the actual beam itself changing over time, and trying to mirror those things together to ensure that what we're saying as an output from our sensors is an accurate representation as to what's happening to the beam. We're also looking at the way that sensors are applied to the beam and trying to understand and see how this changes over time as well.
So you have high fidelity sensors data that is then captured, and from there is to turn this huge, massive amount of data into useful information.
The way the software should work is, as long as everything's working well, you shouldn't have to do a whole lot. In the case that there is an error or there is an issue with the bridge, you get real-time alerts, big red flashing symbols, which really point you to the fact that you've got to do something, and you can actually hone down to that sensor point on that particular girder, on that bridge, what the issue is. You can also have the operational software. So this is actually looking at the hardware installed on the bridge and the roadside cabinets, looking at their temperatures, battery health, and all these sort of things that are critical to actually ensuring we can deliver this service to customers. And that's really important as the asset owners to ensure that the data they're getting off the bridge is in fact the bridge's condition, not other external factors that might be affecting it, but also to ensure that the hardware we have there is in good condition, and if it needs servicing, to make sure that those things can be addressed. I think that real-time element is the big difference between us and other people in the market. It's the fact that you can put it on a bridge and actually understand on your phone in real time what's happening to it and if you need to do something, and depending on what you're seeing, what you need to do as well.